Goes to school 99% of the sunny days, and it is also known that 32% of all days are sunny. Construct a tree diagram to show the probability that Alicia arrives at school. So, first thing is the day can either be sunny or it can be rainy. All right, it can either be sunny or it can be rainy. So I'm gonna write S for sunny and R for rainy. All right. So this is Alicia going to school. I don't even need to put that. All right. It can either be sunny or it can be rainy. The chance of it being rainy is 32%. So chances of it being rainy is 0.32, and chances of it being sunny then is 0.68. The next part of the question now, or the next part of the tree diagram is, given that it is sunny, the chance of her going to school is the audio stopped. My apologies. So again, given that it is sunny, all right, given that it is sunny, chance of she going to school is, it said she go to school 99% of the time once it's sunny. So this is 0.99, and so this is 0.01. All right, so this is the chances of Alicia going to school. So I'm gonna write Alicia AG. This means Alicia going to school. All right, that's AG. Chance of Alicia not going to school, AG prime, is 0.01. Now, given that it is rainy, right, what's the chance that she go to school on a rainy day? She go to school 70% of the time when it's rainy, 0.7. All right. So 70% of the time, Alicia will go to school when it is rainy, and that means 30% of the time when it rains, she don't go to school. All right. And this is the tree diagram for this. Nice and easy, soft. This takes care of part I. That's part I. Let's look at the second part of the question. The next part of the question says, what is the probability that Alicia is at school on a given day? All right, so part 2, the probability that Alicia is at school. So we want the probability that Alicia goes to school. The probability that Alicia goes to school, it is going to be equal to the probability that it is sunny and she goes to school. So it's equal to the probability that it's sunny and Alicia goes to school, plus the probability of it being rainy and she goes to school. I'm using reasoning and logics and symbol. My apologies. Rainy and she goes to school. All right, so the probability of it being sunny and she goes to school is, chances of it being sunny, 0.68. And she go to school, that's multiplied by 0.99. Plus the probability of it being rainy and she go to school is, chances of rainy, 0.32 times, and she got to school, 0.7. That will give you the probability of Alicia going to school on any given day. 0.68 times 0.99 plus 0.32 times 0.7, that's 0.8, 0.8972. That's the probability of Alicia going to school on any given day. So since they were giving us in percentage, we can write there is a 89.72% chance Alicia goes to school. All right, so in general, there's a 89.72% chance Alicia goes to school on a given day. Whether it is raining or falling, there's a 89.72% chance that she's going to school. The next part of the question says, given that Alicia is at school today, what is the probability that it is a rainy day? Given that she's at school, so we know that she's at school. So the probability, given that Alicia is at school, what's the chance of it being rainy? So what's the chance of it being rainy given that Alicia goes to school? So that's the probability of R given that it is rainy and Alicia goes to school. Now this is a conditional probability. The third part is a conditional probability. And the conditional probability is going to be equal to the probability of R given AG is equal to the probability of R intersect AG. It's R intersect AG divided by the probability of AG. All right. Nice and easy. Now the probability of it raining and Alicia going to school is raining and going to school is 0.32 times 0.7 divided by the chance of Alicia going to school. 0.32 divided by 0.7 over 0.8972. 0.8972. Nice and easy. So you work that out, and that will be the probability of it raining and Alicia going to school. So 0.3 times 0.7 divided by 0.8972, which is 0.234. 0.234. All right, rainy, yeah. .249, sorry, mistake when I put this in the calculator, 0.249. All right, so there's roughly a 25% chance. There's a 25% chance that it is raining. There's a 25% chance in this case, all right? Nice and easy, soft. So that takes care of this question. Let's go to part B. Part B. Part B, it gives us a differential equation. It says, show that y plus xy plus x squared is a solution to the differential equation dy by dx equal to y minus x squared over x times 1 plus x. So first thing, start with this. Dy by dx is equal to y minus x squared over x times 1 plus x. All right. Now, I don't like how this looks, so I'm going to separate it as two different fractions. I'm going to write it as y over x times 1 plus x minus x squared over x times 1 plus x minus x squared over 1 plus x times x. Now this looks very familiar to me. X squared over 1 plus x times x If this is dy by dx, I can put it in this form now. And so really and truly what I have is dy by dx plus, I'm going to bring it over now. I'm bringing over this part. I'm going to have dy by dx plus minus 1 over x into 1 plus x times y. That's equal to minus x squared. And then an x cancels out a x from the numerator. So it's really equal to minus x over 1 plus x. What does this resemble now? This resembles this. dy by dx, which is y prime, plus ky equal to a function of x. And so this is a first order differential equation. This is a first order differential equation. All right. So all we need to do is to compute, find the integrating factor. So we need to find the integrating factor. Find integrating factor. So to find the integrating factor, we can call the integrating factor I. And the integrating factor I is going to be equal to, we call the integrating factor I is equal to e to the integral of k dx. So it's e to the integral of 1 over x times 1 plus x. Now, how do you integrate 1 over x times 1 plus x? Well, I'm going to be quite honest, I don't know how to integrate this, but what I do know is I can integrate this by breaking this into partial fraction. All right, I don't know how to integrate that, and so I can just write down that the integral of minus 1 over x times x plus 1, I know that if I bring away the integration sign for now, separate it as partial fraction, I can write it as a over x plus b over x plus 1. Now this looks way easier to integrate, plus b over x plus 1. So I just need to find out what is a and what is b. So let me remove the integral sign for now. So finding the LCM, computing the LCM is going to be x times x plus 1. All right. X into this leaves x plus 1. So this becomes a times x plus 1 plus b times x. That's equal to negative 1. This is a lot of work for 5 marks. A lot of work. So that's minus 1 over x times x plus 1. All right, so this is what we have. Good. Now, all we need to do now is solve for a and solve for b. You can substitute values like let x be equal to 0. If x is equal to 0, what we're going to clearly see is that x is 0, we get a is equal to minus 1. That's what we get for a. We let x be 0, we're getting a is minus 1. And if you let a become minus 1, and if you let x be minus 1, if you let x be minus 1, you're getting that minus 1 is going to be equal to, if x is minus 1, this becomes minus 1 plus 1 is 0. And so you get minus 1 times b is minus b, and so b equal 1. So what that means is all of this works out to just be 1 over x plus 1, 1 over x plus 1, minus 1 over x. Now I can integrate this, of course. So I can rewrite this as I is now equal to e to the integral of 1 over x plus 1 minus 1 over x. And that now works out to be equal to, this works out to be integrating 1 over x plus 1. When I'm integrating 1 over x plus 1, that's just ln the denominator. So it's e to the ln x plus 1, e to the ln x plus 1, minus integrating 1 over x is just ln x. Now, log a minus log b is equal to the log of a over b. So that becomes e to the ln x plus 1 over x. So I get e to the ln x plus 1 over x. And then what happened? E to the ln cancel each other. So this works out to be, so the integrating factor works out to be just x plus 1 over x. That's the integrating factor, x plus 1 over x. Nice and easy. Integrating factor is x plus 1 over x. Nice. Now that we get the integrating factor, we can find the general solution. So step 2, the general solution. All right, so having some freezing difficulties. All right. Okay, good. No unfreeze. All right, so continuing now. All right, so the general solution is going to be y times the integrating factor I, y times the integrating factor I, y times the integrating factor I, and that's equal to the integral of f of x times the integrating factor I. In this case, our f of x was minus x over 1 plus x. So this is equal to the integral of minus x over 1 plus x times our integrating factor I dx times the integrating factor I dx. Right. And what did we get for integrating factor? Our integrating factor was x plus 1 over x, right? Our integrating factor was x plus 1 over x. That's our integrating factor I. And so what we get now is y times x plus 1 over x, y times x plus 1 over x, that is equal to the integral of minus x over 1 plus x times x plus 1 over x. They have minus x over 1 plus x. No, this is a lot of work for 5 marks. This is a lot of work. So it's minus x over 1 plus x multiplied by integrating factor. Integrating factor is x plus 1 over x. Stop freezing. Right. As you can see, this x cancels this x. This 1 plus x cancels this x plus 1. And so we're just left back with integrating minus 1 dx. And the integral of minus 1 is just, the integral of minus 1 is minus x. So this works out to be minus x. And remember, when you integrate, you get plus your constant of integration plus c. And so if you were to expand in y on this side, y times x is just x times y plus y times 1 is y all over x. if you multiply this equation through by x, if we multiply through by x, what are we going to get? If we multiply through by x, what we're going to get is, multiply through by x, we get xy, plus y is equal to x times minus x, that is now minus x squared, plus c, all right, plus c. Now we're finished now, we're done. All you need to do is bring over the x squared to the other side. And if you bring over the x squared to the other side, what you're going to realize is, we bring over x squared to the other side, we're going to get that this becomes y plus xy plus x squared, y plus xy plus x squared is equal to c. Y plus xy plus x squared is equal to c. All right. Now let c equal 0. Just give c the value of 0. Let your constant be 0. Let c be equal to 0. And if c is 0, clearly we're going to see that we get the solution y plus xy plus x squared is indeed equal to 0, a solution to this differential it's a solution to the differential equation. So hence it is indeed a solution to the differential equation. Nice and easy, soft. No issues whatsoever. It is indeed a solution to the differential equation. Nice. All right, we're good. We're good. Now let's look at the next part of the question. The second part of the question says, a differential equation is given by y double prime. So you have y double prime minus 2y is equal to 0. It says find the general solution. To find the general solution, we first solve the auxiliary equation. The auxiliary equation would be, u squared minus 2 is equal to 0. Solving u squared minus 2 equal to 0, we can factorize it to get u minus root 2, u minus root 2 times u plus root 2 is equal to 0. So u minus root 2 times u plus root 2, you get that that's equal to 0. And so what we end up getting is, solving this equation equal to 0, that implies that we're getting u is equal to root 2, or u is equal to minus root 2. And so, because it have unique roots, it have two different roots, then the general solution, which will give us our complementary function, I like to call it yc. Yc is equal to pe to the root 2, pe to the root 2x plus q plus q e to the minus root 2x. All right, that is our minus root 2x. It should be 2 minus root 2x. All right, so that's the general solution. So that takes care of part I. Nice. Now let's look at the next part of the question. It says, hence, show that the solution which satisfies the boundary conditions. It says that y naught is equal to 1 and y prime of root 2 over 2 equal to 0. Hence show that the solution satisfies the boundary conditions. So what that means is, if this is so, pretty much what we're doing is solving for P and Q. It is giving us that, let's start with the first one. It says y of 0 is equal to 1. What does that mean? If y of 0 is equal to 1, then that implies that when you put x as 0, y is 1. So that implies 1 is equal to p times e to the root 2 times 0 is 0. So this is just p times e to the 0 plus q times e to the 0, and 0, q to the 0. And so the first equation that we're getting, I can put it in bold right here. The first equation is 1 is equal to p plus q. So write down this equation. 1 is equal to p plus q. We're going to get another equation now. The other equation that we're going to get, it comes from differentiating yc. So let's write this down. It says, we know that yc, meaning the complementary function, is p e to the root 2x plus qe to the minus root 2x This is what we know. All right, and it says y prime. So we need to find y prime. So to find y prime, all we need to do is differentiate this. So to get y prime, we're going to differentiate it. When you differentiate this now, you're going to get the derivative is equal to, well, how do you differentiate e to the root x? Differentiating that, you're going to get root 2p. You're getting root 2p, root 2p. So you're getting root 2p e to the root 2x. All right, and then you're getting plus, well, when you differentiate this part, you're going to get minus root 2q. So you're getting minus root 2q minus root 2q e to the minus root 2x e to the minus root 2x. All right, so what does that mean? So that means that since this is yc prime, and then remember they had given you this equation, they had told you that y prime of root 2 over 2, they said that y prime of root 2 over 2 is 0. So that means when you put in, x as root 2 over 2, y is going to be 0. So let's do that substitution now. When you put in y as 0, that's going to be 0 is equal to root 2p times e to the root 2x times root 2. Now root 2 times root 2 is 2, 2 over 2 is 1. I'm going to get times p e to the 1 minus root 2q e to the minus, now root 2 times root 2 over 2, root 2 times root 2 over 2, that part give you minus 1. This part give you e to the minus 1. So from this equation, we're getting that root 2, we can divide through by, well, don't divide through by e yet. What we're getting is, I'm going to bring this part over here. So I'm getting root 2q, I'm getting root 2q over e is equal to root 2 P times E. All right, that's what I'm getting. So clearly, these root 2 going to cancel each other. So this root 2 cancels this root 2. And so the equation that I'm left back with is Q over E is equal to P times E. All right, so Q over E is equal to P times E. All right, so if I cross multiply, I'm getting that Q is equal to P times E squared. Q is equal to P times E squared. So we're going to keep a note of these two equations, all right? Q is equal to P times E squared. And remember, P plus Q equal 1. So we have a simultaneous equation. So let's solve it, man. So P plus Q equal 1. P plus Q equal 1. And Q is equal to, I think, P E squared. All right, so all you need to do is, since you have Q right here, you can substitute for P. Q is equal to 1 minus P, and so that means 1 minus P is equal to P times, you don't need to even do that one. Let's substitute Q as PE squared in the first equation. Substitute for Q in the first equation, so you're going to get P plus Q is PE squared. P plus PE squared is equal to 1. How can I solve for P now? Since both of these have P, I'll factor out P, and I'll get P into 1 plus E squared. 1 plus E squared, that's equal to 1. And so I divide through by that now. And so P is equal to 1 over 1 plus E squared. That is P, 1 over 1 plus E squared. Since this is P, remember Q is P times E squared. And so Q is going to be P times E squared, and that will be E squared over 1 plus E squared. That's going to be Q. All right. So Q is equal to E squared over 1 plus E squared. Nice. Thank you. Finally, we find P and Q. So good. So now we're just going to go back to the general solution. Remember, we said that YC was P times E to the root 2x. This was YC, P times E to the root 2x plus Q times E to the minus root 2x. Remember, we said that was that minus root 2x. Yeah, man. Now we're just going to replace with P and Q. And so in reality, YC is just equal to P. P is, let me fix that up. P is 1 over 1 plus E squared, 1 over 1 plus E squared times E to the root 2x. And then Q is going to be plus Q. Remember, Q is E squared. Q is E squared, but when the bases are the same, you can add the powers. So you get E to the 2 minus root 2x over 1 plus E squared. That is it. Nice and easy, soft. Of course, we didn't write it in the form that they wanted. They wanted us to factor out 1 plus 1 over E squared. So we can factor out 1 over 1 plus E squared. We're going to factor that out. And so we're going to be left back with E root 2x. So left back with E root 2x plus E to the 2 minus root 2x. Nice and easy, soft. So As we all can see, this was such an easy question. Easy does it. Soft. And so that is shown. Right? So shown. All right, soft. All right, that was an easy question. Nice. All right. Nice. Well, as you can see, I mixed up the questions. This was actually question 6. So we actually did question 6 and we didn't do question 5. So now we're going to go back to question 5. So I totally skipped over question. I skipped over question 5 and did question 6. That was question 6. So all of this is question 6. All right, let's go to question 5 then. My apologies, not doing it in the right order. All right, question 5 now. I totally missed that. Question 5. Question 5 says, 10 students across the Caribbean community applied for mathematics scholarships. 3 of the applicants are females and 7 are males. The scholarships are awarded to 4 successful students. Determine the number of possible ways in which the 4 applicants may be selected if no restrictions are applied. So if no restrictions are applied, so part 1, no restrictions are applied, that means we can, from the 10 persons, we can choose any 4 persons. So it's 10, choose 4. You just put that in your calculator, 10 choose 4, that's 210. So there are 210 ways. There are 210 ways you could choose with no restriction. 210 ways to choose with no restrictions. Nice. Restrictions. All right, that's the first part. That's just 1 mark. That's the warm-up. It says at least one of the successful applicants must be females. So to do part 2, right, in order, number of ways where you have at least one, you must have at least females. So it's going to be the total ways. It's going to be the total ways minus the number of ways with no females, minus no females. Right, so we need to find the total number of ways minus no females. The total number of ways we just found was 210 minus no females. To have no females mean we would be choosing 4 applicants from how many boys? That is 7 boys. So we're choosing 4 from 7, and we're not choosing no girl times, we're not choosing no girl from 3. All right, that would give us the number of ways of choosing at least one girl. So that will be equal to, put this in our calculator, so it's 210 minus 7 choose 4 times 3 choose 0, 35. So 210 minus 35. And so that's equal to 210 minus 35, 175. So there's 175 ways of choosing at least one female. That's part 2. Now part B. Part B tells us that we have, part B says, numbers formed using the digits 1, 2, 3, 4, and 5 without repeating any digit. Determine the greatest possible amount of numbers that may be formed. And so let's go to this box right here. I like to draw a box and then cut it up into based on the amount of things that they want. So 1, 2, 3, 4, 5. 5 boxes for each digit. Let's say determine the number of digits that can be formed if we're not repeating any digits. So if we're not repeating any digits, right, we can have 5 digits go here. This is the amount of 5-digit numbers. So first I'm going to start with the amount of 5-digit numbers. 5-digit numbers. The amount of 5-digit numbers that can be formed are, in here you can have any number can be at the end, so that's 5. Any number, then 4 other number can go here, then 3, then 2, then only one number can go here. So the number of 5-digit numbers that can be formed is 1 times 2 times 3 times 4 times 5. That's the amount of 5-digit numbers that can be formed. 1 times 2 times 3 times 4, 3 times 4 times 5. So that's 120 5-digit numbers. All right, let's see how many 4-digit numbers can be formed. Again, I like to draw my box. I'm going to draw my box, but this time I'm going to cut it up into 4 pieces. So I know I can have 5 number here, 4 number here, 3, and I have 2. So there is going to be 1 times 2 times 3 times 4, which is not 1, 2 times 3, 2 times 3 times 4 times 5. That's also 120. So there are 120 4-digit numbers that can be formed. All right. There's 120 4-digit numbers that can be formed. So the amount of 3 digits now. The amount of 3 digits. Remember using numbers 1 to 5. All right. So the amount of 3-digit numbers that can be formed now, right, would be 5 number can go at the end, 4, 3. So now I multiply them, that's 1260. So there are 63 digit numbers that can be formed. So there's 63 digit numbers that can be formed. And then how many 2 digits? I can already see the trend. 5 times 4 is 20. So there can be 22 digits. 22 digits. And if you're not, there are 22 digit numbers that can be formed and 5 single digits. All right. There can be 22 digit numbers and 5 single digit numbers. If you're not following, I'll give you some examples to make you understand why this is so. Remember, we're choosing from 1, 2, 3, 4, and 5, right? If you have 1, 2, 3, 4, and 5, how many single digit numbers that you can get? Only 5 single digits, right? See there, 5 single. And if you have 1, 2, 3, 4, 5, how many 2 digits you can get? You can get 1, 2, that's a number, 1, 3, 1, 4, 1, 5. You can get 2, 1, 2, 3, 2, 4, 2, 5. You can get 3, 1, 3, 2, 3, 4, 3, 5, or you can get 4, 1, 4, 2, 4, 3, 4, 5, or you can get 5, 1, 5, 2, 5, 3, 5, 4. How many 2-digit numbers this? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Count up 20. So this will give you your 5 single digits, and this would give you your 20 double digit. All right. So that's how I get the 22 digit. You do the same to get 63 digit, 124 digit, 125 digit. And so the total possible amount of numbers now So the total possible numbers is going to be equal to the total number of 5-digit plus the total number of 4-digit plus the total number of 3-digit, and so on. So it's 120 plus 120 plus 60 plus 20 plus 5, which is 325. So that's part I. Nice and easy. That's part I. Now the last part now, it says find the probability that a number form is greater than 100. So find the probability that a number formed is going to be greater than 100. So the probability that a number is greater than 100 is the total amount of numbers that can be bigger than 100. Those are 3-digit numbers. How many 3-digit numbers are there? There are 60 plus 120 plus 120 plus 120. So there are 300 numbers bigger than 120, and then it's divided by the total amount of numbers, total number of numbers that can be formed, which is 325. So the probability of a number being bigger than 100 is, add up this, divide by 325, that's 300 over 325, 300 over 325, and 300 over 325 is equal to 0.300 divided by 325, 0.923. 0.923. 0.923. All right, 0.923. Nice and easy, soft. That's part 2. All right, that's part 2. Nice. That's part 2. Now, part C. Part C says that a system of equation is given as 2x plus 3y is equal to, let's just write down the equations before we even look at the question. 2x plus 3y minus z, that's equal to negative 3.5. And they give us that x minus y plus 2z, they tell us that is 7. And then they tell us that 1.5x plus 3z, and they tell us that is equal to 9. Okay, so this is what we have. And they say rewrite it in augmented matrix. So let's rewrite this in augmented matrix. So I'm just going to put a line. I don't like to mix different solutions. Let's just put a line over up here. So down here is just part C. So we have a matrix. So a matrix. All right. Let us see. So 2 coefficient is going to be 2, 3, minus 1. Augment. This is going to be 1, minus 1, 2. This is going to be 1.5, 1.5. This is 0, and this is 3. All right, up here now we're going to have minus 3.5, minus 3.5, minus 3.5, 7, and 9. Nice and easy, soft. All right, so that's the augmented matrix. That's part I. Let's look at the next part. It says use elementary row operation to reduce it to echelon form. So to reduce it to echelon form, let's do that here. We need to get 0 in row 1 and row 2 using row 1. So using row 1, right, we're going to let row 2 is going to be equal to row 1 minus 2 row 2, row 1 minus 2 row 2, and then we're going to let row 3 be equal to, that's 1.5. So let me see. It's going to be 1.5 row 1, 1.5 row 1 minus 2 row 3. That's what we're going to do. All right. So we're going to do that. And what we're going to get is row 1 automatically stays the same. So 2, 3 minus 1. And this is minus 3.5. Minus 3.5. All right. So 2 row 1 means 2. Wait, let me see. Row 1 minus 2 row 2 is row 1, which is 2, minus 2 times 1, that's 0. Then row 1, 3, minus 2 times this, so you have 3 minus 2 times minus 1, that's 3 minus 2 times minus 1, that's 5. Just making sure this is 5. Then minus 1, minus 1, minus 2 times 2, that's minus 5 here. This is minus 5. Then you have minus 3.5, minus 2 times 7, minus 3.5, minus 2 times 7, that's minus 17.5. So we have minus 17.5. And then we're going to go 1.5 row 1 minus 2 row 3. So 1.5 row 1 minus 2 row 3, that becomes 0. Then we get 1.5 times 3 minus 2 times 0 is 4.5. This becomes 4.5. 4.5. Then I have 1.5 row 1, 1.5 times minus 1 minus 2 times 3, that's minus 7.5. This is minus 7.5. All right. And then you have minus 1 you have 1.5 times minus 3.5 minus 2 times 9, that's minus 23.25 right here. So this is minus 23.25. Minus 23.25. Nice and easy, soft. Now we need to use row 2 to get a 0 in row 1. So let's continue. So we're continuing. And we need to write that row 3 is now going to become, it's now 4.5 row 2 minus 5 row 3. 4.5 row 2 minus row 3 minus 5 row 3. That's what we're going to do. All right. So again, we now put back row 1 and row 2. Putting back row 1 and row 2, it's 2, 3 minus 1 minus 3.5. And then we'll put back row 2, which was 0, 5 minus 5 minus 17.5. And then we'll go to the big one now, row 3. Now in row 3, as we can see, it is 4.5 row 2. So it's going to be 4.5 times 0 minus 5 times 0 is 0. So this becomes 0. Then we do the same for here. 4.5 times 5 minus 4.5 times row 2, 5 minus 5 times 4.5. That becomes 0 right here. Then we're going to have 4.5 times minus 5 minus 5 times minus 7.5. That's going to become 15. So we get 15 here. All right. Then we're going to have 4.5 times minus 17.5 minus 5 times minus 23.25. We're going to get 37.5 here. 37.5. All right, so that's that. What's the next part of the question? So that's finished. All right, so finish this now. So we use elementary row operation. I'll put it in echelon form. So this is it in echelon form. Echelon form. All right. So this is it in echelon form. So this is the echelon form. Nice. Now what next it says to do now? It says hence solve the system. Hence meaning using this now. So using this now, we can see that 15 times z is equal to 37.5. So if I divide through by 15, dividing through by 15, I will get z is equal to 37.5 divided by 15 is 2.5. And if z is 2.5, looking at right here now, I have 5y minus 5z is equal to negative 17.5. And so I know that z is 2.5. And so since z is 2.5, I can transpose to get y and get that 5y is equal to negative 17.5 plus 5 times 2.5. All right. And so you work that out and you're going to see negative 17.5 plus 5 times 2.5. That's equal to negative 5. And so I'm getting y is equal to negative 1. Y is equal to negative 1. Now that I get y is equal to negative 1, I can back substitute again to find out what is x. Let's find out what is x now. I know that 2x plus 3 times y. So it's plus 3 times minus 1. All right. Minus z, which is minus 2.5, is equal to negative 3.5. So I transpose and I'm going to get 2x is equal to minus 3.5 minus 3 plus 2.5. So 2x is negative 4. And so x equal to negative 2. That is x. X is negative 2. So finally, to write the solutions, I can tell them that x is negative 2, comma, y is minus 1, comma, z is 2.5. If you don't believe it, you can test your solutions in any one of these equations and it should satisfy. Minus 2 plus 1 plus 2 times 2.5. It should work out. Let me check it in this one. Did I do that right for x? Let me see, minus 3 minus 2.5, then minus 3.5, minus answer is 2. No, x is minus 1. Made a mistake right here. Let me edit this. This should be x is minus 2. 2x is minus 2, so x is minus 1. So here x is minus 1 as well. All right. Now that should be fine now. 1.5 times minus 1 plus 3z What is going on? Why these don't add? So clearly we made some error. Let's check again. This z is 2.5, that's good. Transposing, we have minus, we'll bring it over, it becomes plus, then divide through by 5. Minus 17.5 plus 5 times 2.5, that's minus 5. Y is indeed minus 1. Going into the first equation, 2x plus 3y minus z, so that's 3 times minus 1 minus 2.5, that's minus 5.5. Bring over here, minus 5.5, that becomes 5.5 minus 3.5 is positive 2. Positive 2, so many times. Positive 2, so x is positive 1. Positive 1. All right, that should be it now. 1.5 times positive 1 plus 3 times 2.5. Yes, we're good. So this is the final answer. So that is it. Nice. So you can just tell them nice, because you know your answer right. So you say nice. All right, now let's look at the last part now. It says, what if we had show that no solution exists if the third equation is changed to 1.5 minus 1.5y plus 3c equal 9. So the third equation, if we were to change this now, oh boy, let's write it around here. What if we were to change the third equation? So then the whole matrix would just become 2, 3, minus 1, 1, minus 1, 2, 1.5, minus 1.5, 3, augment, minus 3.5, minus 3.57, and 9. All right, so if this was what we had, all right, then of course, what they're saying is show that this have no solution. To show that this have no solution, which is part 4, again, we already know when we row reduce it, what we would get for row 2. All right, so I'm just writing back the same, what we would get. We would get, most of them would be the same. All right, so remember we had used row 2 as row 1 minus 2 row 2. So we had used row 1 is equal to row 1 minus 2 row 2 minus 2 row 2. We were using that row 3 would be equal to, we can use the same again. Row 3 was 1.5 row 1 minus 2 row 3. So it's 1.5 row 1 minus 2 row 3. We were doing that, and what we were getting is, just gonna write back what we got. Row 1, put back row 1 again, which we know was 2, 3, minus 1, minus 3.5. Then remember what we got for row 2. Row 2 would have been 0, 5 minus 5 minus 17.5. Would have been 0, 5 minus 5 minus 17.5. All right, and then row 3 is going to be the only difference now. Right here we know we're going to get 0, but now we have to do some calculations. 1.5 row 1 minus 2 row 2. It's 1.5 row 1, 1.5 times 3 minus 2 times minus 1.5. 1.5 row 1, 1.5 row 1, 1.5 times 3 minus 2 times minus 1.5, that's 7.5, so I get 7.5 here. Then I have 1.5 row 1, 1.5 times minus 1, minus 2 times 3. This is minus 7.5, minus 7.5. All right, and then minus 1.5 times minus 3.5, minus 2 times 9. 0.5 row 1, minus 2 times row 3, say minus 23.25. All right, so that's what we get now. Now the next thing is we need to get here to be a 0, so we'll get a lower echelon matrix. So to get this to be a 0, what we're going to do is, remember we write back row 1 and row 2. So we write back row 1, which was 2, 3, minus 1, minus 3.5. All right. And we have 0, 5, minus 5, minus 17.5. All right, minus 17.5. And then now we need to use row 3 now. And row 3 is going to be equal to, what is row 3? Row 3 is equal to, we're going to let row 3 be equal to 7.5 row 2 minus 5 row 3. So we can let row 3 be equal to 7.5 row 2 minus 5 row 3. All right. This will become 0. And this will become 0. Then we're testing this now. 7.5 row 2, 7.5 times row 2, which is minus 5, minus 5 times row 3, which is minus 7.5. That also becomes 0. But then what this is giving us is 7.5 times minus 17.5 minus 5 times minus 23.25. That's minus 15. Now look what is this. This is giving us, this is telling us then that 0x plus 0y plus 0z is equal to 15. But that makes no sense. That makes no sense. How can nothing be equal to 15? Right? That makes no sense. Tell them that makes no sense. Since that makes no sense, hence the system is inconsistent when the last row is changed to, it's inconsistent when the last row is changed to x, is changed to 1.5x minus 1.5y plus 3z equal to 9. Hence the system is inconsistent when we do that. All right, nice. That's it. So that takes care of the paper for 2015. It was very easy, right? I really hope this would have helped, and stay tuned for more. All right, make sure to subscribe, and all the best preparing for your exam. That's 4 root 5 over 8. That is x squared. All right.